All About Water is a project-based curriculum for K-2 classrooms to learn more about Earth's water, soil, and climate and make the invisible visible. This curriculum is modular, divided into 60-minute blocks, and may be done as a whole or as individual lessons. Activities can also be adapted for virtual and remote learning. More details are provided later in this video. Each of the 3 All About Water lessons are aligned to the Next Generation Science Standards, or NGSS. The complete list of these standards can be found in the curriculum. This video provides an overview of Lesson 2, Filtering Water Through the Earth. This lesson includes 2 60-minute blocks and an optional third 60-minute block. In the first experiment, students explore soil by creating a sediment bag. Then, students use their observations to design their own water filters using everyday materials, followed by an investigation of water samples through a DROUGHT microscope classroom demo. For classes with extra time, the optional activity enables students to explore and analyze water salinity. For all activities, students work in partners or groups of 3. The most effective learning outcomes happen when students have authority to drive experiments and discover key phenomena on their own, creating and sharing explanations with their peers. As an educator, you have a special role to help facilitate this learning process and guide students' understanding by asking leading questions. It is okay if you are unfamiliar with the phenomena, and in fact, this is a great opportunity to model curiosity. In this first activity, students make and observe a sediment bag. Through the sediment bags, students will observe the various components of soil, discovering that soil is made up of many different particles of various sizes. Here's the collection of materials you'll need for this first set of experiments. This activity is done best with a variety of natural soil samples. It is recommended to allow students to gather soil samples from their yard or local environments, which can be returned after the lessons. If you do need to purchase soil, look for different soil mixtures such as topsoil and potting soil from different brands. For best results, this activity requires waiting about an hour or overnight for sedimentation to finish. It may be useful to have students work over buckets or trays to reduce mess. To make a sediment bag, one student holds the bag open while a second student adds their soil sample. Then, carefully add water to the bag until there is water above the soil line. Too much water is better than not enough. Seal the bag, then carefully shake or invert to mix the soil and water. Securely tape bags to a window or wall so that they are out of the way but can be observed while the soil particles settle. Sand particles settle quickly within about 10 seconds, and silt particles settle within about 10 minutes. Clay particles take a few hours to settle, and any organic material will float at the top. After an hour, or the next day, students observe the finished sedimentation. Have students draw lines on their sediment bags to mark the heights of different soil parts, then measure the heights of their lines and record them on their activity sheets. Facilitate a class discussion to understand what happened by asking open-ended questions, such as, what do the different parts of the soil look like? What do you notice at the bottom of our bags? What do you notice at the top? Why do you think that happened? As students provide answers, help label their descriptions with new vocabulary. The second set of experiments includes a design challenge in which students build and test 2 types of water filters. Then, students observe a DROUGHT microscope demo to see the invisible things in water and compare filters. For activity 2, take on the role of facilitator as students experiment with different designs, testing to see what works and what does not. Fear of failure is often a barrier to participation in science and engineering. By taking the time to highlight what didn't work as an important and sometimes humorous learning lesson, We can help students practice working through failure. These are the basic supplies we'll need. This activity works best if students are encouraged to bring in their own materials. It is also recommended to have waterproof surfaces for students to work over. Before you start, add some food coloring, dirt, leaves, or other materials to test water so students can more easily see how well their filters work. Introduce the activity and ask students what they think water filters do and why they might be important. Students work together to build 2 different types of filters. Students should use one bag for their filter design. Modify this bag by cutting the corner off of one side. Use a second bag as the water collection bag. Have students observe the materials and work together to design and draw their filters on their activity sheets. Once they've drawn their design, they may gather materials. When students are ready to test their filter, provide them with 1 cup of test water. One student holds open the water collection bag under the cut corner of the filter bag. A second student slowly pours the test water into the filter. Then, students close the water collection bag and look at its contents. Have students draw their observations and prompt them to think deeper with questions like, what did your filter separate from the test water? What material caught that? What materials do you think didn't work so well? Then, students repeat the filter design procedure to create a second filter by adding or removing materials. Facilitate a class discussion about observations across different groups. The Water Drop Microscope classroom demo helps students see microscopic components in water. Before the demo, provide students with a dropper and a plastic bag. Students and a parent or guardian use the dropper to gather a small sample of water from their local environment. Students can get water samples from their local environment, such as from puddles, streams, or a bird bath. Prep the microscope prior to the demo. Here is what we'll need. Build the microscope by unbending the paperclip and bending one of its ends into a teardrop shape. Bend the rest of the paperclip into an L shape. Insert the bottom of the paperclip L into the clothespin to hold the teardrop shape vertically. Attach the first binder clip to the laser pointer so that the clip holds down the power button. Rotate the laser pointer so that the binder clip rings rest on the table. Attach the second binder clip to the back of the laser pointer with the rings on the table. Use the rings to adjust the height of the laser so that the laser beam shines through the paperclip teardrop. Test the microscope by adding a droplet of water and pointing the laser at a surface. This should act as a microscope for the water droplet. Remove the power button binder clip and put the pieces aside for the demo. When you're ready to conduct the demo, gather the students' water samples. Add a water sample to the microscope, project onto a wall, and discuss observations. For a clearer projection, turn off the classroom lights. compare filtered water to non-filtered water, and lead a group discussion. This is also a great opportunity to talk about the role of water utilities in filtering our water so that it is safe to drink. See the curriculum for some helpful tidbits about how the Metropolitan Water District of Southern California filters our water. After creating filters and seeing the microscopic demo, students should understand that clear water does not necessarily mean clean. In the third activity, students explore and analyze salinity by using electricity to measure how salty a water sample is. It is recommended to have waterproof surfaces for students to work over. To prep for this activity, create 4 or more different mixtures of salt and water. See the activity instructions for mixture suggestions. Prior to the activity, ask students, can we filter seawater and drink it? Encourage students to think and talk with their friends and families about this question. To start the activity, have one student hold open a bag and a second student fill the bag with a saltwater mixture. Close the bag partway. Insert the LED into the JST connector so that the longer leg goes into the hole for the red wire. Unbend the paperclip into a J shape. Hook the loop over the side of the bag so that the straight end of the paperclip rests in the water. Tape the bare metal of the red wire to the positive side of the battery. The battery must be 3 volts in order for this to work. Tape the negative side of the battery to the bag on top of the paperclip so that it rests snugly against the paperclip. Insert the black wire into the water so that the bare metal sits in the water but is not touching the paperclip. Then, check if the LED is on. Observe the brightness with different saltwater samples. The more salt that is in the water sample, the brighter the LED will be. After the activity, facilitate a class discussion focusing on observations. It may be beneficial to draw a line graph of increasing salt with increasing brightness. This curriculum is adaptable for virtual learning. For specific suggestions, watch Lesson 1, Water Cycle, and read through the virtual considerations section in the curriculum. Suggestions for further exploration of key concepts can be found in the extensions section of the curriculum. And that concludes Lesson 2 of All About Water, Filtering Water Through the Earth. More details about the science behind each of these activities and the demo can be found in the curriculum Science Overview section. Thanks for watching, and be sure to check out the next set of activities in Lesson 3, Droughts.